There are objects in our galaxy that are very different from ordinary stars and planets. Their density is 20 trillion times greater than the density of ordinary matter, which is why it seems that they do not belong to our universe. Neutron stars are the remains of ordinary stars, which by their properties belong to another world. A neutron star is formed from an ordinary star at the end of its life, if its mass was from 8 to 40 solar masses. When all the light elements burn out, the star begins to cool and contract. Under the influence of very high gravity, this contraction becomes explosive and is accompanied by the release of a large amount of energy. The brightness of the star increases from 10,000 to 100 million times, and we can observe the appearance of a supernova. The outer part of the star is scattered into space, forming a nebula, and the inner part continues to contract. Its atoms break under the influence of strong gravity, electrons are absorbed by protons, and a super-dense core consisting of neutrons is formed. When a supernova explodes, not only the substance of the outer shell is ejected into space, but also the outer part of the neutron core. Trillions of pieces of the neutron star of various sizes begin their journey through the universe. There is no limit on the minimum size of the already formed neutron matter. Neutrons are held together not only by gravity, but also by nuclear forces. There is no reason for such formations to disintegrate. Let's call them conditionally, neutron matter, NM. In total, in our galaxy alone, there are about 1 billion neutron stars, each of which, when exploding, could scatter trillions of NM, its pieces of various sizes, into space. Considering that they move at sublight speeds, their collision with the Earth is very likely. What will happen if a NM collides with the Earth? Everything will depend on its size. If it is large, it will move to the center of the Earth, or more precisely, it will move the Earth around itself and become the core, and make the planet its shell. After that, it will gradually begin to heat the shell due to accretion absorption, but we will not know about it, because as a result of such a cataclysm, the Earth's crust will mix with the mantle. If the piece is smaller, it will tear off part of the planet and take it with it. If the piece is even smaller, it will pierce the Earth through and through, like a bullet through smoke. Explosions will remain at the entry points and the entry points of the fragment. The speed of the NM in space will be high, but it can decrease due to their collision with each other and the influence of the gravity of celestial bodies. The probability that the speed and direction of the NF will coincide with the speed and direction of the Earth's movement is extremely small, but in the event of such an event, we will get a very interesting picture. It can enter the Earth's orbit. This orbit can be very low, including passing directly at the surface. Neither mountains, nor especially air will create any obstacle to the movement of the NF due to the large difference in density. Although it will spend most of its time moving high above the surface or, on the contrary, deep underground, it will make holes in buildings and people if they happen to be in the path of its movement. All cases of collision will be accompanied by explosions due to the high speed of movement. And finally, it can enter an orbit around the center of the Earth, moving inside the planet under its surface. The density of an iron weight is 6,000 times higher than the density of air. So at not too high speeds it can fly freely through the air without noticing resistance. The density of the NM is 20 trillion times higher than the density of the soil, so the NM can move freely through the soil as if through empty space. Rotating around the center of the planet underground, the NW will release a large amount of energy due to friction and absorption of matter. This will lead to heating of the Earth from the inside. This is why the Earth is hot inside, due to the rotation of the NW around its core. It is this movement that leads to the formation of volcanoes, which create an atmosphere and water on the surface. The NM also rotates quickly around its axis. Having a small electric charge due to the absorption of electrons, it creates a magnetic field around the planet, which protects it from solar and cosmic radiation. The NM gradually absorbs the planet's matter and causes it to shrink and contract, which leads to the swelling of the surface and the formation of pointed mountains. Over the next 10 billion years, the NF will completely absorb the Earth. This is how the Earth differs from Mars and other planets, the NM moves inside the Earth and therefore it is seismically active. There is no such thing inside Mars, and therefore it is geologically dead. Just as its surface is dead, the movement of the NM causes seismic waves that can be easily recorded by instruments. However, the movement of the NM inside the Earth is clearly visible without instruments, by the waves in the form of stars that rotate on the surface of the ocean. Their movement can be seen on the tidal map.